Usually has. This one usually works a little bit better. This leg has been having a lot of trouble. But all he does, he kind of skitters along, and the antennas, when they're working right, if you touch one antenna, he thinks that it hit the wall. As it turns out, the antennas are kind of tangled, and so he always thinks he hits a wall dead on, and he tries to back up. What's supposed to happen is if you hit just one antenna, he thinks he hits a wall and turns away. Well, we proved there that we could get the motors. There's a much more complicated gate. He's running low on batteries, so he's kind of dragging a little bit, but a little bit better antennas, but the same algorithm. He's got the 18 motors, which allows him to pick his feet up and move them, so he's much more efficient, even though he's still a bit skittery. We haven't hooked up the solar panels. What else can I talk about?
That's a funny dance.
Because there's no resistance when he pulls his leg in. He'll stop and go back the other direction, or reach out and try to grab a little bit more.
有 force feedback 㗎隻腳。
So this was a little bit smarter.
幾極啊？
One of the neat
唔
things
使
we can do,
antenna 呢個有
since we put our own springs not in here, is there's a little bit of compliance in here, which means that if he falls, he's less likely to break. It turns out, though, that if you do that demo really hard, push really hard, you really do break the leg, and then he doesn't work the next day. So you don't get to see him crawling.
我哋而家排緊咩啊？咖啡豬啊
Mission control 啊！
撞鬼啊！
main floor controlling 3 different communication complexes around the world. We have one at Goldstone up the Mojave Desert near Barstow. We have one in Madrid, Spain, and one in Canberra, Australia.
What do we see? Boy, the Deep Space Network did such a fantastic job for us in light of the Spirit and Opportunity landings. They really saved us. You know the old proverb that if a tree falls in the forest and no one is around to hear it, did it really fall? Same thing can be said for the landing. It's just such a fantastic job those guys did for us.
The Deep Space Network comprises 3 equidistantly spaced deep space communications complexes around the world. One here in California, one in Canberra, Australia, and one in Madrid, Spain.
Opportunity, a Stardust, still track Voyager, we're tracking Cassini, or they're finally getting to Saturn.
The Deep Space Network is a fabulously sensitive instrument that is used to track 3 dozen spacecraft per year. In addition to the telemetry...
Feeding you, so that you get the most amount of points possible. So that makes it an interesting.
How come they're going by themselves? How come that one's going by itself?
Stop, pull that.
That one's got a broken sprocket.
What?
Can you say that again?
For grades 4 through 8, there's a competition called First Lego League where Lego Mindstorms are used, and then and those
Type 4
similar to this.
係咪呢條友好似唔識控制佢咯？好明顯。
That's what we're measuring on the spacecraft.
All right. Thanks.
How metaphysical do I want to get here? Ultimately, their purpose is to explore, and specifically, their purpose.
What's up there? 係咧，有班僆仔咧，跟住係咁喺度碌。This is so cute.
Going to hopefully launch in 2009, be the next rover on the surface of Mars. It'll be about 5 times bigger than Spirit and Opportunity and be able to do a lot more science, have a much longer lifetime, hopefully 1 year to 2 years of extended mission. And
2009嗰個 rover 原來係咁大架嘅 SUV 咩？喂，抽提子開咗，抽提子咁大個。
Sandbox is quite literally a dirty job. Some engineers and technicians, to avoid ruining everyday shoes, keep a special pair that they wear only while in the lab. The bright and dusty lab has 90 1,000-watt lights to simulate midday Martian light conditions so that the team can properly calibrate rover cameras. Although Mars is farther from the sun than Earth.
工廠嚟嘅，但係自己工廠冇人擺到咁凍嘅啲嘢。呢個嘢氹氹住唔知做乜嘅咧？做緊，喂，篤緊佢，轉緊佢。呢個唔知做乜嘅咧，褪嚟褪去嘅。
That's why we go to great pains here to minimize the weight on our parts.
What I have for you here is something that I think will kind of hopefully put together in some context the things you've been seeing today. This is about a 20-minute video presentation that talks a little bit about the history.
Talents of robotics, rovers on planets, navigation, communication. JPL is a cornerstone of our Mars program. Partially it's in-house at JPL, but it's also some goes out-of-house. It's shared with industry and universities. And I think that's a good relationship.
Our goal is to get the best capabilities that exist in this country. So we reach out to the university, we reach out to industry, we reach out to other NASA centers to bring the best talent and the best ideas and the best capability to really make sure that our nation stay at the forefront of space exploration.
Systems looking good. Think we are now supersonic.
And in a sense,
the Earth is extremely dynamic, down to plate tectonics, to earthquakes, to the core. We can measure volcanic eruptions, but we can measure what goes on before and after a volcanic eruption. We can do the same with earthquakes. We can measure earthquakes and we can measure how things change before and after earthquakes. And this is very exciting. We no longer are only just measuring the shaking part of the earthquake or looking at the geologic record. We're actually measuring the Earth as it moves, as strain builds up, as stress builds up, and we can watch that break. So we can see the entire earthquake cycle for the first time. Ultimately, we like to forecast earthquakes or predict earthquakes. It will certainly help us understand the earthquake hazard better. The thing that's really...
They feel, particularly my wife, is as committed to this as I am. I mean, she, in a sense, you know, when it came down to, do I want to work on MER, do I want to try work on the 2000
spacecraft to the planet every 26 months. Each of those spacecraft is finely tuned to studying an aspect of the planet. So it is the advancement with each mission of our knowledge and the tailoring of future missions based on what we learn today.
These machines do our exploring for us. They become extensions of ourselves. We build them with brains. We build them with eyes. The MER rover has an arm that's like exactly the same dimensions as my arm, same length, elbow, wrist, shoulder, okay? We build them to do our work for us, and you can't. You simply, if you've got a heart beating in your chest, you cannot pour the energy into these vehicles that we do and not become attached to them emotionally. I mean, I can't help it. I cannot avoid that. I don't try to, okay? I mean, I love those rovers.
The only moon in the solar system with an appreciable atmosphere. Titan from a distance, Titan from even up close, looks like a big basketball. You could write Voight across it and you could be convinced it was a basketball. The Huygens probe is the first mission that we have sent, which is designed to float. If there are lakes of liquid ethane and or methane, which we think there are, this thing will float and hopefully will survive splashdown or landing to send back data from the surface of Titan. After orbit insertion,